All right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up where we left off last time, or last night, rather, with eliminating more code. We actually have a couple of more things to sort of figure out, but overall, we're going to be eliminating some code. So, before we get into that too much, though, I do just want to take a quick second just to thank the supporters of the channel, starting with our elite partner, Javier Lazaran, followed by our partners, Gaboli's Inc. and Matt Oscard. They are the highest tiers of subscription over on YouTube memberships and Patreon, followed by our supporters, who are listed here on the screen. They are all a combination of the other tiers of support on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me to cover the cost of hosting the channel. Things like software licenses, hosting fees, eventually assets, things of that nature. So thank you all very much for that support. It's greatly appreciated. And I would be remiss if I didn't mention all of you guys, the viewers, who are either joining me live here on Twitch or YouTube, or if you're catching the VOD rather after the fact. Without you guys, this channel and thus this project would not exist. So thank you guys very much for being here. I appreciate each and every one of you. All right, so just catching up on chat really quickly. Magat's good to see you. Nick, good to see you as well. So the translucent WES term background, is it a custom window rule? Yes, but I also have I guess you could call it an extra script that's installed that allows me to actually do that. So it's not something that comes with KDE out of the box. Shoot me a message on Discord, and I'll throw you a link to what it is that I use to get that to work. Because it's too much to go over on stream. It's not hard to set up, but it's enough that I don't want to necessarily do it here. But yeah. All right. So, as you can see here, we are actually looking at the scene file. And we have the static mesh over here. I've actually completed, I think, the implementation for this. We do have a couple of to-dos and fix-me's. But I think for the most part, we actually have this complete. Obviously, I didn't do anything with the shutdown, but that's not, like, huge, right? So I think I've got all of this figured out. It was mostly just taking logic that we already had in sort of the resource handler for this, and then just, kind of refactoring it to fit in with all the stuff we talked about last night. So I really don't think I need to go through this line by line. I think most of it should make sense once I actually upload this code and you guys can see it. So I'm probably not going to go through that in detail. It's pretty much everything we talked about beforehand and how we were going to approach it. It pretty much worked out that way. So obviously, once we get to the point of running, we'll see how well this works. Speaking of that, when I go to build, obviously the reason I'm in the scene file is because that's what's causing the errors right now. So we have a little bit of work to do within the scene, mostly around the query functions, right? So where we query either based on proximity of a 3D line, or we query the other place is going to be queried based off of a view frustum. So both of those queries basically need to be updated. We've got 15 errors in this file, and that's pretty much between the two of them where they all are. So we're going to go ahead and take a look at that. And I think after this, I don't believe there's much, if anything else, that needs to be handled. So we'll go ahead and take a look at that. Spiro, good to see you as well. Good to see you here, buddy. Thanks for being here. Appreciate it. You should do a comprehensive NeoVim config and guide video on YouTube. I could do. The problem is that stuff it becomes out of date really quickly, right? So that's why I actually have I actually have a command here in the chat that points you to an article that I wrote with all of the NeoVim stuff on it. So that actually shows you all the plugins that I use and what they do, and then points you also to the NeoVim config, which I think is probably about 98% up to date. There may have been some small tweaks I've made here and there. I probably need to update it, but for all intents and purposes, it's there. I suppose a video could work, right? But like, I don't want to have to keep doing that like once a year or something like that either. I don't have time for that. But maybe. I'm not going to completely rule it out, but that's the reason I kind of haven't done it so far. All right. So, what we need is essentially for both of these queries, they both need to know the same thing. And those things are, we essentially need to obtain a static mesh count, a sub-mesh count, really, of the static mesh. And then from each of those static meshes, we need a geometry as well as a material instance for that. So we do have the sub-mesh here. I don't think beyond getting the geometry and the instance, I don't think we actually need that. So I think what we can do is probably just edit our static mesh interface to give us three things, right? So probably a submesh count so that we can loop through those. And then a way to get the submesh geometry by index. And then also a way to get the material instance by submesh index, right? And that should give us, I think, everything that we need to actually complete this code here. And I think from there, we can actually make this work. Long term, what we're going to want to do is we actually do have something in here called static mesh render data generate. And so long term, once we move this and we refactor out the render graph stuff and whatnot, we're going to want to make use of this guy to generate the data for us. And I even have a fix me here to say, we need a way to filter this down, etc. So I don't know if that's going to happen here or externally. We'll have to determine that. But essentially, for now, I think we're just going to extend our static mesh interface to include a couple of these things that we just discussed. So we're going to have, let me move this up so I'm not coding behind my head. So we're going to have all of these things are going to return a Boolean to indicate true if successful, false if it failed. And the only thing that really should cause it to fail is if we don't pass a state or we pass an invalid static mesh. Let's see. I guess we should probably go by the instance, right? And then we also need a submesh count. So I feel like we could probably do a lot of that. We could do some of it through the static mesh and then some of it through the static mesh instance. So let's say static mesh, and then we'll say submesh count get. And we'll do struct static mesh system state excuse me. And for this one, we are going to do k static mesh m, right? And the last thing that we're going to need is, I think, the max number of submeshes we can have is, I want to say we use the U16 for that. So we're going to take a U16 pointer, and we're going to say out count, right? And so that's going to be the first function, right, to give us the number of submeshes we have. And then we'll also do a static mesh submesh, and we're going to call this get at, right? And so the difference here is going to be that this is going to take all the same properties, except it's also going to take a U16 index, right? So we'll get the submesh at that index. Now, we don't actually need to return like a structure like this. We don't actually need that. what we really need is we need the geometry and the material instance. So let's actually change this a little bit further. Instead of actually outputting a count, we're going to say k geometry, and we're going to say out geometry, right? And we're going to say submesh geometry get at, right? And then we'll have the same thing here, only for material instance get. And I know that's kind of long, right? But that's okay. Material instance. We're going to say out material. So these three things will basically allow us to fill in this loop with everything that we need for that. So let's go ahead and implement these. And we're going to put this here. We have a couple things actually here to implement that I forgot about, but we'll get to those in a minute. So let's just turn these into function definitions, right? So the submesh count is basically just going to have to do a lookup and then return the number of submeshes that we have. Now there's two ways that we could do this. We could say we could return false if it's not loaded, or we could just return 0 if it's not loaded, right? Which I think either way would be fine, because either way we're not going to wind up going through this loop if we have a count of 0. So I think I'm just going to go with the count of 0 if it's not loaded. Otherwise I'll just return the count, right? Let's see. NeoVim help pages are fine. Can't figure out where to copy and paste them because it doesn't clearly say what file to modify. Yeah, so it is in your config nvim init lua, I believe, is what it is. Yeah. Config nvim init lua. And if you have other files that get included, right, this is where my config file is. So I've actually set something up to allow me to edit this, like from NeoVim just by a quick keystroke. But yeah, that's essentially where that is. Okay, so the first thing we need here is we need to say if we don't have state or m equals invalid static mesh, or, and I actually want to put this beforehand, not out count, right? Because we need those three things in order to successfully handle this. So if we don't have those things, we're just going to return false because there's not really anything that we can do there. Otherwise, if we're good on that front, then we should be able to just return, or not return rather, but set the value pointed to by out count equal to state, let's see, that doesn't need to be struct. So state, and then I think it's, why am I not getting my, I do have, do I not have, is my IntelliSense broken? Yeah, I think it kind of is. All right, I guess what we really need though, let's say state, and we'll just look it up manually real quick. We are going to want submesh data. So submesh datas, sub m. Submesh datas, sub m. And then we're going to want the submesh count, right? So we're going to set the value pointed to by out count to that, and then return true. Why is my auto formatter also not working? It's almost like the whole thing pooped itself once I opened the NeoVim config. All right, let me do this. Let me relaunch real quick. Maybe that'll help. Or not. Okay. Regardless. There it goes. Okay. All right, so all we need to do here is return the submesh count. That should be good to go. So the next thing is the getting the geometry at, right? And so this is going to return, let's see. Actually, I want to rethink this a little bit. So this function, and actually material instance is going to be the same thing. We're taking like a pointer to out material, right? And a pointer to out geometry. Instead of actually doing this, why don't we just make it return that? Right? And then it's null if it's invalid. So material instance, right? Instead of doing it this way. Right? Simplify things a little bit. We'll do that here too. So this is going to be K geometry pointer, and then we could do material instance pointer. And actually, now that I'm thinking about it, those should probably be constant. Because we shouldn't be, we shouldn't be modifying those. So we'll need to, we'll need to go back here to the header and just modify that. Okay. So once again, we'll do a sanity check here. So we'll say if we don't have states or the static mesh is invalid static mesh, or index is equal to invalid ID U16. If any of those things are true, then we're going to go ahead and just return, instead of false, 0. Technically the same thing under the hood, but let's be explicit. Otherwise, we're going to return the address of state. In this case, we want the geometry, so we're going to go base, submesh datas, sub m, and then we're going to do submeshes, sub index, and we want the address of that, right? Let's see, that's a submesh. Oh, geometry, right. There we go, okay. And this is going to wind up being almost the same thing down here. Let's see. This is going to wind up being, instead of geometry, it's going to be, we have material name here. So this is going to wind up being, instead of submeshes, it's going to be base instance datas, sub m, instances, and that's going to be sub index, and then material instances. Let's see, wait a minute here. That doesn't seem right. Yes, okay, that should be right. Okay. All right, so for these 3 pieces of data here, that will give us everything that we need to handle this loop. So over here, when we're actually cycling through the submesh counts, we'll have U16 submesh count, and we're going to say that is equal to 0 to start with. And then we'll go ahead and do a static mesh submesh count get. We'll do engine systems get static mesh system. The static mesh itself is actually going to be m mesh. And then the out count is going to be the address of submesh count, right? And so we'll get that. And then here we'll change this to a U16. And we'll do just submesh count. And then we actually don't need this. We don't need this at all. The k-geometry G is going to be equal to static mesh geometry get at, right? So this is going to be engine systems get static mesh system. I do know I need to get rid of those engine systems gets and use, cache it and use that instead. We'll come back to that. So we want the mesh, and then the index is going to be J, right? So that's going to be that one. Let's see. And that should be a k-geometry pointer. That should be constant, though. And then the material instance. The material instance. Oh, that's why. Okay, that's why this felt wrong. I knew there was something I was missing here. Let's go to... This should also be, instead of actually just taking the static mesh, should be instance. Right? That's where we are going wrong. So this should be the k static mesh instance. Right? We should take an instance for that. And so we want to do the mesh. It should be instance mesh and then instance ID, and then also check or index equals valid ID U16, right? Okay. So this should return instance.mesh as the sub there, and then instances is going to be instance.instance ID, and then we use index. That is correct. Okay. So over here we have now a pointer to the instance, a constant pointer rather, and this is going to wind up being let's see, so static mesh submesh material instance get at, right? So again, engine systems gets static mesh system. Again, we'll fix that in a minute. So the instance is going to be M, right? So that's going to actually wind up being dereferenced M, and then the index is going to be J, right? And so we'll get that, and then we'll have the instance there, and that should fix most of it, right? The only thing that we need to do is go through here and fix some of these things that were pointers, or that are currently not pointers, and just fix them to dereference instead. So let's see, has transparency. That just needs an arrow operator. Let's see. Let me catch up on chat real quick. Keep up the good work. Thank you over there, Kremlin, on YouTube. Appreciate that. Apotham, good to see you. Welcome. Open Room is asking, what's up? How's the engine going? It's going well. I did get a little bit of stuff done offline to move us forward. So now I think I have the static mesh system mostly straightened out. There's still a couple things that are left to do. And now I'm integrating those changes to that system into the scene, which we're eventually going to move. But I just need to get it working for now. So that's kind of where we're at the moment. 10x developer, good to see you as well. How many people are using this engine? Well, using, it's hard to say because it's still pretty much in its infancy, right? However, let's see. Let me pull up the repo. So here's the repo. There's 97 forks of it and 1.2k stars. So if that gives you kind of an idea of where that stands, I guess, that's something, I guess. So like I said, it's very early days still. It's not something that I would recommend using for production yet because we're still tweaking it. It's still under heavy development. There are still things that are getting changed around, mostly for the better at this point. We're actually removing complexity as opposed to adding it at this point. But yeah, I hope that kind of gives you an idea. As far as how many people are using it to actually make a game yet, I have no idea. Because they're not required to tell me, right? Thank you for the follow, Friendly. Appreciate that. Vulkan first engine. Yes, it is Vulkan first. If you mean that it was developed with Vulkan in mind as a first-class citizen, then yes. We didn't port it from an OpenGL engine or something like that, if that's what you mean. Okay, so the second thing to fix is going to be this loop, which actually, I believe we can actually just copy pasta some of this stuff, right? So we can actually just take this. I'm actually just going to take this bit, and I'm just going to paste it here. And so I can get rid of those lines, right? And then, well, let's see, we got a couple of errors here. So mesh instance. Why didn't we take we should be taking a pointer to this, I think. Let's do that, which is going to require a couple more minor changes, but that's okay. Okay, so I think the only things we have to fix here are the same things that we had to fix above. Okay. So in theory, this should hopefully get us one step closer. Okay. That's not a surprising error. So K-resource system. So I went ahead and deleted this resource handler, right? Because we're done with it. But now the resource system is bleating because it can't find it, which makes sense. Because I did not remove the reference to it. So there's that. And then this, right? So essentially what we're doing is we're stripping out all of these handlers one by one. And deleting the code with them, and then this whole system is going to go. Static mesh system 363. Oh, I think I know what the problem is here, actually. Yeah, there's two things here that don't return anything. So we have a tint get and a tint set, but we don't actually have that in our state. So that is done by instance, which means it's going to be part of the instance data up here. So along with this, we are going to have vec4 tint. And And actually, this is going to be an array of those things because we're doing the whole structure of array thing. So we're going to say tint indexed by instance ID, right? Which means that we're going to have to create that array at some point. But for now, let's go ahead and fix these errors, or warnings rather. So we should probably go ahead and do, I guess we'll do this number. Right, so we'll say if not state or not out tint, then there's not really much we can do. Otherwise, if we're actually, I think we can actually just say states base instance data's sub instance mesh, and then we want instances sub instance ID, and then we want tints. Wait a minute. We need one of these per. Well, this sets the whole thing for all submeshes, not by index. So technically, this isn't true. Tint, let's just say, let's simplify this for now. Tint used for all sub meshes, right? We're just going to have a single tint. If there's sub meshes, they get applied all the same. If we need anything outside of that in the future, we can add it. But for right now, it's basically just going to be applied across the board. Yeah, it should be tint, that's a vector 4, and so we can dereference out tint and set equal to that, and then return true. Right, okay. So that's the get. The set is going to be a little bit simpler. So all we need to do is, actually it's not really much simpler. It's just going to be, oops. It's just going to be that. And then we don't have to check out because we don't have that. Okay. Engine.c, static mesh system initialize. Right. We added a config structure to that we need to now fill out. You going to support OpenGL? First time I've heard of this. I might. I haven't really decided whether I want to or not, Coffee Lava, to be honest. Good to see you, by the way. My plan is to support Vulkan, and then the next thing I'm going to support is going to be Metal, because that's the next biggest thing. Because I really want to get off using Vulkan on macOS, because that relies on Molten VK, so I want to get rid of that dependency. So that's going to be the next one I do. And then after that will probably be Direct 3D12. And then maybe I'll do... The only thing I'm thinking about having OpenGL support for is like really old hardware that doesn't support some of the Vulkan features that I'm requiring, or mobile. It's the only thing I'm thinking there. Because if you've done any programming for using Vulkan on mobile, it basically requires a completely different backend to the way that desktops work, which is not something I'm really wanting to do. Let's see. Singy, good to see you. How's it going? Shimoda says, how did I end up here? Pretty sure I was looking up math lectures. Yeah, we haven't done one of those in quite a while here since we wrote our math library, but welcome if you're interested. Yeah, it's good to have you here. Mobile is a headache, I hear. Yes, mobile is a complete and utter headache because of the fact that it works completely different to how desktop GPUs do. And so essentially it would require almost a full reimplementation of about 60% of my Vulkan code, probably 60 to 70%. Constant updates needed or you get delisted. Yeah. Yeah, that's the other thing, right? And so, OpenGL on mobile is just kind of an easier way to go. You're not going to get some of the features. You might not get as great performance, if we're honest, but, it'll work. Isn't it the same with OpenGL and OpenGL ES, or is it better in a way? I thought the Vulkan spec was the same even for mobile. So the spec is the same, but the thing is, what changes is, it's not like OpenGL ES would be for mobile, right? Like it's not like that. It's the same Vulkan spec, but the problem is the features that are available versus not available, and the way that you have to set up like your render loop and stuff like that. There are differences, right? Like the way that I'm doing it for desktop is basically I have a sort of a render target that I render to, and I render all of my scene and everything to that, right? And then I take that and I blit it to the swap chain image. On mobile, that's a terrible idea. It's super slow. Yeah, there's tiled rendering you have to consider on mobile as well. There's also like dynamic rendering. Good luck getting that on mobile. Probably not going to happen, right? Which means you got to set up all the render pass crap and all that other stuff, which has weird tie-ins to pipelines and other things. So it's just like not something that I really want to get into, I think. Yeah, render passes and sub passes, exactly. Like I eventually got so tired of dealing with that stuff that I just went with dynamic rendering because every desktop GPU basically out there supports it. But yeah, it's kind of a headache to do on mobile. So it's like it's one of those things where like if I were to do it on mobile, I would probably just make a completely separate Vulkan backend for mobile. Who plays games on their phones anyways? Yeah, I know, right? Don't you guys have phones? It's kind of like that. All right. Let's see. Where were we? Okay. Engine C. So we needed to add a configuration structure here. Because that is what it requires. So we need a static mesh system config. Really? Mesh system config. And then the only thing that we need is application package name, which I don't... Do we actually have that at this level? I don't recall. I don't know if we have that at this level. I might actually have to add that to configuration, which is really annoying. But we should probably have it at this level anyway. The reason we need that is because we need to know sort of what the default package name is going to be when we start up the application. So, how do I want to handle this? I could add something to app config where you have to add it. But that seems kind of lame because I think our app config already has... I think our app config already has a reference to it. It's just got a list of packages that it uses, though. Oh, we do have something for the asset manager. Okay, so we might actually have to just do the same thing. That's kind of annoying, though. I feel like this ought to be a higher level thing. I feel like that should be... I feel like that should be probably like a higher level configuration option that it just can pull from the app config regardless. Because I don't want to have to do this, right? I don't want to have to take this and then also find my... actually... I don't even think I have a config in here for this. And I don't want to have to parse one. See, because this actually has to do that thing. Yeah, I think I'm going to hoist this up to a higher level in the application config. I think that just makes more sense. Let's maybe call this under package config. Let's call this default package name, right? And so we'll essentially say the default package name anytime we need a default package name, where we don't specify a package when we're actually loading an asset. This is what we specify, right? So we just pull the default package name from that. I think that makes sense because that's more high level. Then we don't also have to have it kind of all over the place, right? Which is kind of annoying because I already had this in here, right? But it is what it is. It is what it is. Let me go to here and remove this. So I'm not going to have this anymore. Or this, actually. I'm not going to have either one of them. Actually, you know what? Let me take both of these. Again, we'll go to application, not generic system config. I guess we probably ought to go with straight to app config. Which we do have package config here. I'm wondering if it should be even higher level than that, right? Maybe it should be like up here. Let's do that. Let's do that. Let's take this. We're going to say default package name. We're going to hoist that all the way up. Let's see. Isn't Vulkan overkill on mobile phones anyways? Mobile isn't a real platform. Yeah, I know. Vulkan kind of is overkill for that. For sure. In fact, I'm writing my own game for mobile primarily, and through my impression, I get more FPS on iPhone 14 than my Dell laptop with a UHD 620. I could believe that. Android recommends Vulkan. Yes, they do. But it doesn't mean that you can't use OpenGL. Here's the problem with mobile, right? And I suspect we may have the same issue with Metal. But, so for an iOS device, it's going to have to be a Metal implementation. But I suspect that is probably also going to be the same deal, where we're going to have like a separate Metal implementation for mobile versus desktop. So I might wind up having to do that anyways. That's why I haven't really decided on what I'm going to do with it yet. I could just kill two birds with one stone there on mobile and just say I'm going to use OpenGL, and not support things like ray tracing. But I don't know. We'll see. Yeah, 10x developer, it did. It did censor that word for some reason. Give me a second real quick. My fan over there is making a really weird noise and it's kind of annoying. Give me a second. Okay. So this is going to be the default, I guess the name of the default package to be used when loading assets if one is not provided. All right, so we'll do that, which means that we're also going to have to do I'm going to have to add some stuff here to the parsing. Let's see. So I think probably, oh, we have some unsafe string stuff in here I probably ought to update too, but let me not get too distracted. Let's see, manifest file path. Here we go. I'm going to take this, copy paste it, and we're going to say default package name. And we're going to have default package name and outconfig default package name. Did I not? Oh, I think it was, what the hell did I call it? Still had application package name. Let's get rid of this, right? Because at that level we don't have k-names. So we'll have that. And then we'll also have default package name as required and application config. If it's not there, we're going to bleat about it and boot. So that's all that's needed there. Let's go ahead and get rid of this because we don't need that. And okay, so now we can pull that directly from application config if we need that. I suppose the other thing that we could do, let's put a str back on that real quick, right? Oops. Let's put that here, and then we'll also do kname default package name, right? And then we'll also have, you know, the kname set up when we actually when we want to go to use the kname, so we're not constantly having to generate it all over the place where we want to use it. And so what I can do is here, after we have that, we'll do, what was it? Out config default package name, rather, equals kname creates, and then it'll be out config default package name string, right? So we have the kname available for that as well. And then we can go back to engine and down here, we're going to have equals, what was that? App config, that's what it was. It's been a bit since I've looked at this. Default package name. There we go. And that is all hooked up now. So all I need to do here is say config, and then come down here and do the same thing. Boom, done. Okay, in fact, I guess I could just put that on one line. The other thing, this should create an error in the asset system. So the asset system is now trying to take the application package name, which it should not be doing. So we're going to eliminate that because it doesn't exist anymore. And then, let's see, config. I guess the config should probably actually still have default package name, right, as a K name. Should still have that. So then when we go to engine, and we are where was the asset system? Here it is. Asset system config. After we deserialize, we'll do sysconfig default package name equals app config default package name. All right, and then in asset system, we have this guy, which is just going to be default package name twice. Let's see. Okay, this is a string duplicate. We don't need that. All we need to do actually is kname string get. And then we have that. And that should be everything that we need. I'm also going to rename this to default package name. And then rename this to default package name string. Okay. K actors. I think I'm going to ixnay that whole system, actually. The whole K actor thing, I don't think I'm going to use that. In fact, I know I'm not going to use it. So we're going to delete some more code. Let's see, that's under submodules, Kohi, runtime, source world, and then K actor. I don't think there's anything of value in here actually, anymore, that is. Yeah, not really. It's a bunch of to-dos. So let's get rid of this and get rid of this. And I think there's going to be something including that probably. Nope. All right. So in theory, it should run. Let's see. Let me catch up on chat. How's your gaming coming along? The engine is being made along with it, right? Or is the foundation still needed? Yeah, so we're working on the game and the engine in tandem. And what I'm working on right now is actually we are simplifying some of the engine systems and APIs to make writing game code a little bit easier. So we're kind of in a mode right now where if we don't need it, we're removing it, and we're trying to simplify things to make things a lot easier to use. We did a lot of experimentation with different systems and trying to make things generic, just to kind of show how you might approach that kind of thing. But ultimately, I've elected not to do that for the long term of the engine, right? So all of those generic things, instead of making them generic, we're going to hoist off that responsibility to the game code and have a game-specific implementation of those things. For example, the scene, right? So yeah, we're going back and forth between the engine and game code at the moment. What do you think of ECS? I find it looks cleaner from a point of architecture since data and logic are completely decoupled. So yes, but also no. Because it's one of those things that tends to take the problem and it doesn't actually deal with the problem. It sort of abstracts the problem and says, well, the user will just handle this down the road. And I got thinking about this. I did a lot of thinking around this. And I was just talking about actually making the scene game specific. And having to use an ECS kind of gets around that problem, but not necessarily in the right way for all projects, right? So I would argue that most simple projects or relatively smaller scale games don't need an ECS at all. And so we kind of played around with trying to make things generic in this engine, and ultimately I came to the epiphany, if you want to call it that, that the game itself, or the game logic, is fully aware of the data that it needs, how it needs to interact with that data, how that data should be laid out in memory, all the logic surrounding that data. The game knows all of that, right? So why are we going to try and then make this generic one-size-fits-all thing, which we are then going to have to definitely either override somehow or plug things into or try to extend in some way, when we could just say, hey, instead of going generic, why don't we create something specific? Because we know the types of data we're going to be dealing with. We know exactly how we're going to be dealing with it. Why don't we just write that kind of stuff in the game code? And so I'm going to take the scene out of the engine or the core engine. And the scene is going to be the responsibility of the game code, because the game ultimately knows what it needs in a scene. The game knows what a scene is. A scene's definition is going to vary by the type of game you make. So having a one-size-fits-all scene doesn't necessarily always make sense either. And so what we might do is create sort of like a generic scene eventually as a plugin to the engine if you want to use that. But ultimately, this is going to be designed in such a way where really the application / game code should be defining how that stuff is set up and run. So yeah, I hope that makes sense. Wonderpaw says, I find Kohi's code too defensive. What do you mean by that? That's an interesting, I've never heard anything put that way before when it comes to that. What do you mean by too defensive? Let's see. Let me catch up over here on the other side. Know where you're coming from, but the iPhone GPU feels even more potent than an M1 MacBook Pro, which is actually what I'm using to stream from right now. So I think Apple might actually use the same metal for both phones and computers. They probably will, right? So I think it'll be just like Vulkan in that respect. It'll be the same API, but the features that are available and the way that you'll have to structure your code will vary between the platforms, I think. I say that without having actually tried it, but I suspect that's going to be the case. So unlike GL and GLES, which technically have separate APIs, kind of, this will be the same API, but branching on feature availability. Heard Metal is a really good API, but I don't own a Mac. Would be fun to play around with. Yeah, so Metal is going to be definitely the next rendering backend that we write. And that's going to be interesting because I've not ever actually written anything for Metal. So I'm going to be learning that on the stream as I write it, which should be interesting. Closest thing that you have to Metal is SDL3 GPU, but it's third party. So what I have seen is actually Web GPU is actually really close to Metal in terms of API. Thank you for the hydrate, posture check, and stretch redeems. I appreciate those. Hear me out, ECS, but there's only one component in one system. I mean, maybe. Sounds like maybe doing bounds checks or null checks where it's undesired. Maybe. Maybe that's what defensive means. A lot of assertions, checks for failure result, instead of, for example, let null pointer crash your program. So, this kind of, I mean, okay. So, things like this, right, where we check for state existing. Sure, we could, assume that we have the state being passed in here, right? But anything that's assumed or anything that's exposed to user code is not something that you should necessarily assume that the user is going to do correctly. And so I usually like to check these things and actually, if I don't have a state to work with, or if I don't have an output to write to, why am I going to try and do this, right? I would much rather return false than try to do something and crash. And where I'm really thinking about this and where stuff like this is probably going to be used a lot is in a scenario like an editor where you're trying to put things together, but things aren't fully ready all at once, right? Because you kind of have to piece things together and load things ad hoc. And so I kind of feel like I would rather be a little bit more defensive, to put it that way, like this than not be. And just kind of always think about that in my code. That being said, probably once we get things a little bit more nailed down, I probably will go through and change a lot of these to debug asserts, which basically are options that get run on debug builds, but then on a release build, they're a no op. But right now, it's like, while we're still putting stuff together, I actually kind of need these checks in place to make sure that everything's good. And then we can remove a lot of that stuff later once we've battened down the hatches, What about engine systems like renderer physics? If you want to iterate through all that data in an array, doesn't ECS solve the problem? So again, like, you don't need an ECS to solve that problem. I mean, just deal with the data directly. You don't need an ECS for that. You don't need the overhead of an ECS for that. Are you a solo dev? On this project, yes. There have been people that have committed code to it, small things here and there, with the exception of I did get a big boost from somebody for the initial implementation of the Mac OS layer before I had a Mac to port to. But yeah, for the most part, it's been all me. Yep. WebGPU seems to be going nowhere fast. Yeah, I mean, it's you can actually use it now, but it's not anywhere near as widely supported as WebGL or WebGL2 even. Basically, two implementations of it are not the same. Massive resource usage for a basic triangle. Lots of memory leaks, and okay, yeah, see. And that's kind of the reason I haven't touched it yet. It's too new. Still preview on Safari, maybe in a few more years. Which, the irony of that has not escaped me, because Apple has been one of the ones pushing really hard on things for WebGPU. So maybe some of it's better. Yeah, maybe. But, I mean, even WebGL has issues like that still on occasion that I've run into before. So, I don't know. If I were to write a web game engine, it would probably still be based off of WebGL, I think. What about example as a transform component? Game and engine use this data equally. Many engine and many engine systems can touch this data. So you'd have a transform system that deals with transforms, right? But you don't need an ECS or a component for that, right? It's just a transform. You don't need a generic system to say, well, this is a component that contains a transform. You just have the transform. Right? Like you don't need all that extra layer of interface and all that other stuff. It's just more layers of indirection to go through. All right. Let's see. Where was I? I don't even remember what I was doing. Okay, it did build. So let's run it so we can see how it crashes. All right, so far so good on that, but I think it's going to poop itself when I try to load. Yeah, not surprised. What did I miss? Let's see. So this is mesh asset loaded. Okay, so see, this is exactly why I pass state, right? So state is type listener state. We didn't set it somewhere. So that's something. Why didn't we do that? All right, so mesh asset loaded. Not surprised I missed that. So listener. Oh, what a dingus. I allocated the listener, but I didn't actually set up any data on it. So this is going to be just M. Dingus-oriented programming at its finest, folks. All right, let's try this again. There's probably more stuff like that I've missed, but we'll see. All right. So we can move, right? We see that our water has loaded. Like we've obviously got a texture there. But we don't have any static meshes loaded. So that's neat. Okay, and we've got some issues on release 2. So we'll figure out these things one at a time. I think what I'm going to do first is let's look at the console log. Okay, so this is just an issue with audio. That's probably our emitter trying to do something stupid. Let's see. Do we have... So this is the water textures loading, default skybox. Okay, so from what I'm seeing here, the test cube was requested twice. The tree was requested once. And those jobs never finished, right? We can see here they were assigned to job threads, but they never finished. Right. So I guess let's check that out. I think I'm going to have to debug my way through that one. So let's, I guess, set some breakpoints. Oh, I need... This is probably going to be VFS, because we jobified that recently. Well, no, that's not going to be the issue, because textures do load. So it's not going to be there. I guess let's put a breakpoint here, because we don't actually, I don't think we spit anything out to the console when we actually do this. Okay, let's do that. All right, load. Geometry count is 1, so we're good. So we just get a bunch of stuff. Geometry count, 1. Perfect. Okay. So we loop through, we get all of this good stuff. We have a name there. We set up the submesh geometry. Did we actually set the submesh count? We did. Okay. Take a copy of the index and vertex data. We upload it. So we allocate from the render buffer, then we upload to the render buffer. Same for the index data. That has been done. Let's see, the generation here is invalid ID, so that should now be, well, that'll essentially be 1, right? Or 0, rather. Let's see, so states sub m. So this is the first one we're loading. We flip that over to loaded, right? So we have this. Let me just make sure that that's actually getting set. Yep, it's loaded. Okay, and then we acquire material instances for each one of those, which I don't see anything being written here, so that's a little bit sus. And then we release the asset because we no longer need it, which makes sense. And then we free the listener. That should be it. That should be all we need to do. So that makes me wonder if the problem is in our scene, where we go, let's see. Let's see, I guess it would be submesh counts. Let's make sure that these work, right? So let's put breakpoints here. Okay, so we know the mesh load in theory is working. I can crank up render doc, but oh, interesting. Okay, so that is interesting. So we're not even hitting these breakpoints that I put in scene, which makes me wonder if this is not doing the thing correctly. Mesh count is 3. So why is that not getting hit? If mesh is loaded, oh, that should be not loaded. What a dongus. All right. Let's see, that was like 2100, I think. If we are not loaded, is loaded. Yeah, so we should only count loaded ones. Here's another one. Okay, I got it right on one of them, but not all of them. Okay, let's run again. Okay, I'm going to turn that off for right now and just continue. Okay. So, what have we here? minst. I'll bet that's null. It is. So why are we getting null there? Let's try again. Okay, so this should be, we pass the mesh instance and then the index of the submesh that we are looking for, and we get the material instance for that. So yeah, we know about that one. Let's see. I guess we need to pull apart this, right? So instance, mesh and instance ID are both 0, but I think that's actually correct. So it should be giving us that. Well, let's see. Without ECS, how do systems iterate over needed transforms efficiently, in a tight loop like for transforms? I agree, not all games need this, but it still looks natural as DoD design. So again, it really depends on what you're doing with those transforms, right? If you're just doing a bunch of multiplications to, well, okay, so there's multiple things that you'd want to process on a transform, right? So first you have building the actual matrix from the transform, which requires multiplying the position, rotation, and scale together, right? Or making the matrix from those things. And so that's one set of operations that you have to do. Ideally, you'd probably also have something that maintains some sort of dirty flag, or better than a flag, you would have all of your dirty transform data in one array and all of your clean transform data in another array, so that you only iterate through dirty transforms. You would update those, and then you would have to calculate the world transforms. And so what you would generally do there is there's kind of a two-step process there where you go through and you get all of the matrices for in the order that you need to multiply them in, and then you pass that off to a job that does that. So that job could just be a function, for example, that takes 8 transforms at a time and multiplies them in a really tight loop. And when I say transforms there, I'm talking about just matrix multiplications, right? So you really just have to split out your work based off of the actual operation that you're doing at the time. So generally speaking, you wouldn't want to pass like a transform structure around that has all the data in it, because generally speaking, you're not going to need all of that data all the time. Either you're going to be dealing with positions or the rotations or the scales. Maybe you have to deal with all 3 to generate your matrix, right? But then when you're going to actually get the world matrix for all of that stuff, you don't want to have to be passing through a huge tree of transforms just to do your matrix multiplications, because you're just going to blow your cache lines out all over the place. So generally speaking, you'd want to iterate through that, build yourself a list of transforms that have to be multiplied together, and then that way you can just do all that work all at once. So you just have to kind of split it out that way. So like having a high level iterator that just goes over structures kind of prevents you from doing that. Let's see. Catching up on chat over here. Personally, I hope to never have to touch OpenGL again. Yeah, we all say that. Eventually, there will be some reason to go back to it, I'm sure. You think WebGPU will never succeed? Oh, you hope that WebGPU will never succeed, so you can continue to use WebGL. And Apple will have to support WebGL. At the same time, they will probably not phase out OpenGL. So I don't think, I know on Apple devices, OpenGL 4.1 is the latest you can use. But that being said, I don't see anybody phasing out OpenGL anytime soon, because it's just going to break too much stuff, quite frankly. And so I think what is going to happen, if it hasn't happened already, is eventually OpenGL will become just an interface point, and all of that stuff will be abstracted to the real sort of GPU architecture under the hood, whether it's DirectX on Windows, or whether it's Metal on Mac OS, or Vulkan, or on Linux or what have you. I think probably some of that's already happening potentially. It's really up to the GPU driver makers as to how that works, but I think that's going to be what happens. Like OpenGL as an interface will still be around. It won't get any updates, but I don't see it going away where they can say it's deprecated, right? It's been deprecated on Windows for 20 years plus. But I don't see it going away, right? It would just break too many things. From what I understood, ECS solves large-scale entity counts of hundreds, thousands, and so on. So again, it depends on what your use case is, right? So the thing about ECS is a lot of people try to punt it as this one-size-fits-all solution, and it's just not, right? There are places where it makes sense, but generally speaking, for like smaller or simple projects, it's overkill completely. Apple broke a lot of stuff phasing out Flash. Yeah, so, but I feel like Flash is kind of a separate thing, right? Because like Flash was kind of like a third-party app anyways, right? It was kind of always this third-party extra thing. It was akin to Java applets back in the day that used to run in the browser, right? Like it just good riddance. It's not quite the same though as something like WebGL, right? I get what you're saying, but yeah, it's not quite the same thing. Let's see. How do you store shader data? I found that you can create one huge storage buffer which contains everything in vertex index data for all shaders. I'm working towards that. I still have stuff separated out right now just to give me nice, clean little containers. So I have a giant index buffer, a giant vertex buffer, and then internally I have per frame data set up for that too, so that I don't have race conditions, because we can have multiple frames in flight. So within that, it's also segmented per frame. So eventually I probably am going to, combine it all into one massive buffer, but I haven't done that yet just because it's a little bit easier while you're developing to kind of containerize your data that way and segment it off. Instead of potentially being able to, overwrite, further into the buffer than perhaps you meant to. So yeah, for now they're separate, but eventually, and they'll always be separate as far as the API is concerned. Like the engine's renderer API will always keep it separate, but under the hood they will be eventually the same, all in the same buffer. Hope that makes sense. Just makes it a little bit easier to wrangle issues when they come up while we're in development. All right, so we have base instance datas. So let's take a look at this. Okay, so we have one instance count. So we want to get the first instance, right? Now, we do have, this is why it's failing right here. So material instances, the material instances array does not exist. And we're only getting away with this because we happen to be hitting index 0. If this was index 1, it would be pooping itself right now. But because index 0 is basically the same as saying just material instances by itself, that's why we're getting away with it. Okay. So why doesn't material instances material instances exist. Acquire material instances. I wonder if this isn't working right. So let me just kind of step through the code here. So this is basically saying if the state of that instance ID is acquired, we should probably check that too, actually. So there's this, which is loaded. Okay, so that should exist. Let me grab this again. And we'll do states uninitialized. Right, okay. So we have not retrieved an instance for this. Why not? So when we this one probably should have happened here. Oh, because we didn't actually flip the flag anywhere. So when we are issuing a new instance, we say, let's see if we can find a free slot, use it if we do. If we don't find one, we expand the array and then use the first slot in that newly expanded territory. But either way, we don't actually do base states, and this is going to be instance ID equals k static mesh instance state acquired. We don't actually flip that flag. And because we didn't flip that flag, it didn't do any of the other initialization that it needed to do. And thus, we are up the creek without a paddle. All right, so let's see if that fixes it. All right, cool. Requires a non-zero size. So what are we trying to allocate at a 0 size? That would be this. Probably submesh count 0. Yep. So did we do this too soon? Issue new instance. That's going to be a problem, though, because we don't yet have a submesh count because the asset hasn't actually finished loading yet. Okay. So we should do this bit, but this bit down here, we have to do one more check, right? So we actually have to check the, actually we could just do this here. If states sub m is not equal to loaded boot, right? We probably, for acquire material instances, we should probably, actually, I guess we should probably check that before we even call this. I mean, I suppose this is fine. But one thing we do need to check is we do an issue new instance. So if we don't do this here, then we need to do mesh asset loaded. When this is loaded, and we do acquire material instances here, actually that might fix the bug. What I did there might be sufficient. Or not. Well, okay, now we've got something else. So setup frequency states, internal shader name. Okay. Cannot get shader for a material using an unknown material type. Okay, so let's check here through the material instances array created. So we're requesting the material system to give us new materials. Oh, that's something I hadn't thought of either. Okay, so we jobified our asset loading, right? Which means that we throw that off onto another thread to happen. And when that loads, then we get a callback that says, hey, this thing is loaded, and then we actually do the thing, right? We actually upload whatever data we need to the GPU, or whatever we need to do depending on the type of asset, right? So I believe we have static meshes working fine now. The problem now is actually with our material system, which we haven't really had a chance to exercise at all. So the problem here is, for the material type, the default type is unknown, which is conveniently 0. So when we load a material asset, essentially, or I should say when we request a material, the way that this works is we have a base material and we have a material instance, much like we do with static meshes. And so we say right off the bat, okay, we don't have this base material, we need to load it. We're also going to go ahead and create an instance for that. And we're going to stand up what we can until we get that asset that comes in. The asset that comes in is what tells us what type of material it is. It tells us what the lighting model is, all this other stuff in here, right? But we don't know that until the asset comes in. So what's happening is the material is not loaded yet, and we're trying to use it. And it's basically saying the material type is unknown because it hasn't actually loaded yet. And I don't believe we actually have a state for material, right? So what we're going to actually have to do for this is, I think we're going to have to say, if the material is not loaded, then use a default material until that material is loaded. And then we can just use the proper material once it's loaded. But we don't actually have a loaded state, right? Because before everything was synchronous. So whenever you requested material, it loaded the file off disk, did all the setup for the material right then and there. And then by the time that request was done, you had the material. It was loaded, it was ready to go. Now that stuff's asynchronous, we actually need to have some sort of check for that. So I guess we'll go to material system H, and we'll have to put in here. Actually, we don't need to expose this. We can actually put this. We can put this back here. So let's see. Oh, water type material. We did that. I think we did this too. All right, so in here we'll type def struct, and we'll do material state, right? And we're going to do material state uninitialized is going to be 0. And then we'll do material state loading, right? And we don't actually need to set that. And then we'll do material state loaded. Oh, I said struct. I meant enum. I was like, why is that giving me an error? That's valid syntax. Okay. So our material state will eventually have to, will essentially tell us whether or not we can actually use the material. I think that makes sense. Why don't you use include in shaders? Shaders can share the same data. It's 4 3 frames in flight that you need 3 buffers for shaders to read data to avoid erase condition. Wait a minute. There's a couple questions there. Okay, so we don't need 3 buffers, right? We don't need that. We have 1 buffer that's split in 3, or split in however many frames per flight. Frames in flight, rather. So that's one thing. That's already a solved issue. Why don't you use include in the include directive in shaders? So I will at some point, but the reason I never bothered to do that is because right now we're using GLSL for our Vulkan shaders right now, right? But eventually we are going to have MSL for metal and HLSL for DirectX. And so that's going to require that we approach it one of 2 ways, right? We either write all of those shaders in the individual languages, which sucks. I don't really want to do that, but that's one way of actually handling it. Or the other way, we have sort of our own quote-unquote shading language that essentially gets transformed into the appropriate language before compilation. And that is actually the route we're going to take long-term. So our OpenGL, our GLSL implementation for loading in shader logic and all that stuff right now is temporary. Eventually, we are going to have our own shading language that we parse and transform into GLSL, MSL, or HLSL, and then forward it off to the backend appropriately, right? So our shader system is going to handle that for us, based on what the rendering backend does. It will handle its own part of that, and then that's just how we're going to do it. So essentially, the way that it would work is when we have our own language, that shading language will have imports, and we'll essentially build out the whole file that is basically got all of the imports, swapped out with what they're actually including, right? So we'll generate the whole essentially file, right, just in memory. And then we'll take that whole huge text blob and we'll shove it over to the render backend and say, hey, here's KSL, if we want to call it that, right? Kohi shading language. Here's the entire shader. Throw that to the back end. And then the back end doesn't have to worry about handling includes or any of that stuff. We do all that in the front end and we throw it to the back end as all one large bit. That's the eventual goal. I don't know when we're going to get there, but that's the design I have in mind for it. Let's see. Instead of having hundreds or thousands of entities, it would probably be best to just handle that entity type outside your entity system. Yeah. Fisheye cam? I don't think so. Is it? I don't know. Was it fisheyeing for something when I was like doing all this? Did it? I don't know. It doesn't look very fisheye to me, but maybe I'm not seeing what you are. It looks. Well, I guess it kind of is a little bit, isn't it? It's just kind of a cheap webcam that I have up here, right? I should probably upgrade that at some point and get a higher quality camera, but I figure the image is only so big on the screen, so like if I go to here, it looks kind of crappy, right? Because it's only just a cheap webcam, right? I mean, the Mac one is actually a little bit better, but the angle kind of sucks, right? So looks wide angle, the lines are not parallel. Yeah, I can see that when if I pull this up. Yeah, I can see it like right there. It's kind of hard to point like that, but yeah, that line right there is definitely, yeah, I see what you're talking about. And also over there, for sure. Anyway. Thought you had as an effect? No, I think it's just the way this camera does it. I don't know if it's got like, I don't know if I can adjust that at all, or it's got like a little focus thingy, but I don't know if or how it works, to be completely honest. It's just kind of a cheap webcam thingy. So, all right. Let's see. Where was I? So, material instance data. So the material data. And this is also very, like, this, we need to reorganize this in like a more DoD friendly, cache friendly thing. But I'm not going to worry about that for right now. We'll do that another time. So we have type model. Let's do after name. We'll do material state, right? The states of the material, loaded versus not, etc. Right? And so by default, it's automatically going to be uninitialized, which is perfect. And then when we do on material, let's see, chaos at material loaded, in here, we do actually need to swap. So let's see. Create the base material. Maybe we could do it in here. Like towards the end, I think. Yeah, towards the end of this is probably going to be good. All the way down here, actually. We'll do actually right before the return. State equals material state loaded. Right, so we'll flip that there. And then material loaded, wherever this gets made. So when we request the asset before we return, or I guess we could do it even before that. We could do, let's see, out instance material equals new handle. Poop. I think I'm actually going to have to go to, here and here. I need that. Right, so when we do this, we then need to say new handle, and then material state equals material state loading. right? And then one last thing that we need to do is whenever we destroy a material, let's see, I think that's going to be down here. Structs galore in this guy. Material destroy, I think. Here we go. So let's see, material. Material type. Okay, I think I can actually just do it here. So whenever we destroy a material, we're going to say material state equals material state uninitialized. Right? So immediately mark it as unavailable for use. Right? So we've at least got that. Now we need a way to say, is this material loaded? Yes or no? We don't care if it's loading. I don't think we need to expose that externally. I think we can literally just get away with saying, is it loaded? Yes or no? And so, let's see. I think we have, actually, let me see. Material texture get. I think what we're going to do here is do a B8, and we're going to say material is loaded get, right? Struct material system states, and then we'll do khandle material, right? And this is going to do two things. So first off, if we have a invalid material or whatever, we're just going to say it's not available. We're going to say it false, right? Which is works regardless, right? So if it's invalid, it's obviously also not going to be available. So it just kind of works. And then the flip side of that will be if it's loaded, and only if it's loaded, do we return true. Right, so we can actually just grab this, and we'll say if not states or khandle is invalid material, we're just going to return false, right? Not available, not loaded, whatever. Return data state equals material state loaded, right? And actually, we probably don't even need to do all that fanciness. We can actually just we can do that, right? And so now what we'll do is we've got a way to check to see if a material is available to be used. And if not, we can get the default material. So when we go to, let's see. Oops. I think we were doing, oh, was that in the, I think that might have actually been in the scene. Yeah, material instance, here we go. So we get the material instance from this, right? If this is not available, then what we can do is just kind of swap that out, right? So we can do if not material is loaded get, right? Engine systems get material system And then the material itself is going to be on minst material, right? So if that's not available, then we need to do material. Do we have get default? Let's see, this is going to be for static mesh, so we probably want to use default standard, right? Engine systems gets material system. Yes, I know I need to save those off at some point. This returns a material instance, right? So this is actually going to... we should probably... cache that instance, right? Because what this is literally doing is this is actually going to stand up a new instance of the material every time, which we don't want to do. We basically just want to have one instance of the default material to fall back on if the material is not loaded that we're trying to use. Because otherwise that would be really bad. All right, let me see. Let me catch up on chat. Thought it was a full frame digital camera with a wide angle lens. Boy, was I wrong. Looks incredible though. Background lights are doing magic. Yeah, I guess so. I guess it looks better than I thought. I always thought it looked kind of poopy, but there's a group of people working on Glue. The goal is to make languages that use LLVM to interoperate natively. I think it's a good idea in general to break the language barriers. What about programming in an IR? I assume you mean intermediate. IR directly. Yeah, cutting the language layer. You mean shading languages, or like all programming languages? Programming languages. Programming and do you mean by IR? Do you mean intermediate representation? Yeah. I don't know. I haven't thought about it. Good question. To make languages that use LLVM It could be a good idea. I just wonder about how that would work cross-platform, right? I wonder about cross-platform. That would be the biggest thing for me. And specifically platforms other than what you just see on your typical desktop environments. How many textures are there per material? I see you have must have a diffuse texture and then separate textures for metallic and roughness. Can you explain that a bit, please? And what is the AO flag? Okay, so the way our materials are set up is, so let's see, there's the diffuse slash, what can I think of the word? Albedo, right? So that's one. Normal is another one. And this is for PBR lighting model, right? We also are going to have a couple of other lighting models, but this is for PBR. So for your standard material, it'll be your diffuse slash, I just said the word, now I forgot it again. Your diffuse slash, oh my God, why can't I think of the word? Brain. Anyways, you have your diffuse, your normal, and then there are two different ways that you could go. So there's, you have your roughness, your metallic, and your ambient occlusion, right? You can have those as separate textures, but they only really require one channel of data each. So there's also this thing called an MRA texture that you can have that uses all three in one texture, and just uses RGB of that. And so that's the recommended way to do it. But the reason I split it up like that is because in a context like an editor, generally you're not going to have, you might have one of them but not the others, or you might have them all as separate files as an artist, right? And so eventually we'll have a way to bake that together. I actually have a utility that can do that, as long as the images are all the same size. But for right now, I basically wanted that flexibility to have them either as separate images or as a combined MRA image, which is metallic roughness, ambient occlusion, to make it a little bit more performant, right? And then there's flags that you can set as to what textures you're actually using. So there's that. There's also emissive, which the texture channel exists. I don't actually have it hooked up in the shaders yet, beyond just existing. So there's that. There's also an environment map for irradiance. So there's that as well. And then obviously it needs the shadow map as well. So the cascading shadow map, which is layered texture. So that's 4 layers in our case, but it's a layered texture. I think that's it. And then aside from that, for a water material, there are a couple of other maps that you need. Instead, you need a DODV texture and a... actually, that's the only other one. No. So there's DODV texture, and then there's also what we call renderable textures, which is your reflection and refraction. So you have a color and a depth texture for each one of those as well. And those are generated on the fly. Diffuse can bake in shadows, while albedo is pure color without any shadows. Yeah, albedo is the word I was trying to think of, and brain farted. Yeah. So I don't do any shadow baking. This is all... It's all dynamic shadows for everything. But yes, that is more or less the difference. All right. CM Griffing rating with a party of 43. Oh, Chris, how's it going, my dude? Thank you so much for the raid. Let me do a shout out real quick. Mr. Sir, how's it going? What did you get up to on stream? Hope your stream went well. Thank you so much for the raid. I really appreciate it. We are actually just wrapping up here, but before I do that, I'll just give a quick introduction as to what the heck we're doing on this channel. Working on my GitHub as a database thing. Yeah, that I saw that a little bit. I didn't get to watch the whole thing, but yeah, it looks pretty neat. But yeah, if you guys aren't following Chris, definitely do it. He's always doing crazy fun stuff over there on his channel. He's always kind of playing with new tech and lots of different stuff going on over there. So definitely give him a follow. Nick Wan rated me as I was rating it. Yeah, we're ending at the same time. Yeah. So before I end, basically what we're working on here is something called the Kohi game engine, which is a game engine written in C, using Vulkan as its initial rendering backend, because I plan on supporting Direct3D as well as Metal as well. It's a game engine written from scratch, and it's designed to be sort of an educational series. So it's a way to build a game engine. It's not the only way to build a game engine. It's not even necessarily always the right way to build a game engine. We try a lot of different stuff. It's experimental. We try stuff that works. We try stuff, obviously, that doesn't work. And then we do a deep dive into why, right? It's cross-platform. It runs on Windows, Linux, and Mac OS. I can't actually run it right now because it's busted because of the updates I'm doing, but I'll get to that in a second. It is open source. It is free and open source, so it's available on GitHub. I'll drop a link in chat there. And so it's Apache 2.0 license, which basically means that you can use it for whatever you see fit, whether it be commercial or personal. Does not matter to me. All that I ask is that if you use the code here, that you just say you used it. That's literally it. Since this is kind of an educational thing, I believe that stuff should be free. This knowledge should be free. I'm hoping to motivate people to get into this into this line of work so that we have more competition out there, because I think that is what drives ingenuity. Anyway, as a result of that, I do not paywall anything having to do with this game engine, and never will. There will never be any sort of royalties or license fees of any kind. This will always be free and open source. So the website here just has a couple of other links on it. We do simulcast to YouTube and Twitch. And then we've got a Discord server with about 1,000 people on it, and a GitHub link here, a Patreon. I don't have any sponsors, so that's basically the only sponsors I have is you guys, and then we have the stream down there at the bottom. So what we're doing right now is we are actually doing a little bit of a rework on some of our asset loading. We've made it asynchronous, and we're kind of dealing with some of the fallout from that. But we're also simplifying our APIs, and we're actually cutting out a lot of code and complexity. So we're actually trimming things down quite a bit. And so we are actually developing a game on this in tandem. And so obviously, like I said, I can't run that right now. But, I do have some, albeit aged screenshots here of our basic PBR pipeline. But we are making a 3D isometric action RPG. And I'll just leave it there for right now as far as that goes. But we're building the game and the engine in tandem. So the engine is really being exercised by us building the game. And yeah, that is basically about it. So I hope that all makes sense. You heard Kohi game engine at first? Like Kohi and Cambria? Yep. Yep, I know exactly what you're talking about, Chris. That's very funny. Let's see. Okay, cool. So yeah, again, thank you for the raid. And I would ask, if you guys aren't following me already, please do, whether it's on the Twitch side or the YouTube side. It helps me grow the channel, and like I said, I'm trying to motivate people to get into this space, and give us more great technology that isn't run by huge corporations and bloated, right? So yeah, that's pretty much my my diatribe, as it were. All right, so I'm just gonna find somebody to raid real quick. Let me just look through my list. Let's see. Yes, I know who I'm going to raid. We're going to raid Els Dragoon, because they are still online. They are a duo, an artist and a programmer, working on a game in 6502 assembly that actually runs on the Nintendo, the NES. So we're going to go over and see what they're up to. But yeah, thank you guys so much for being here. Thanks again for the raid, Chris. I really appreciate it. And I will see you guys next time. See ya.